All right, I think let's get started. Yeah, I have to unmute. Cool. I will be talking about, as Shrivat said, we are a team of SREs, and we actually solve problems at our customer side when things run on production and keeping the lights green. That's the primary job. I'll talk about what all we do beside an SRE, but who all know this? Yesterday, yeah, it was all on my timeline. By the way, who's also flying today or tonight? My flight got cancelled, and my parents stay in Delhi, and they're like, "Oh, are you coming? तू आ रहा है कि नहीं?" मैं कहा वो तो इंडिगो उड़ाएगा तो मैं आ जाऊंगा, नहीं होगा तो मैं यहीं रहूंगा. Sorry. Yeah. Cool. So how we use and leverage large language models to improve incident response time. This is very very specific to one of our customers that we were working with. So those of you who know SREs, great. Those of you who don't, a quick brief primer. Core responsibilities of SREs is it's a thankless job, keeping the lights green. But whenever you push a code to your version control system and force that to take it on production and keep things running, that's what we come in and our day-to-day looks like. You end up setting up a lot of your observability infrastructure. That's quite a hot topic. You try to set up some threshold, some alerts on top of it, and try to have those incidents. This is where the money starts worth to the business stakeholders. कि इसको पैसा दिया तो थोड़ा काम में आएगा, right? You have your incident responses. You have to identify, do capacity planning, how your systems are scaling, the throughput is increasing, and of course prepare yourself for failure modes. Well, failure mode is not that failure mode that Srivat's plugged in, but you have to anticipate that your systems can go down at any time, from your disks to your computers, to your VMs, to your data centers, to whatnot, to your internet lines, to your powers, and whatever that you can think of for your packet to route. Usually 3 success metrics or key metrics which are identified and associated with SREs that they are trying to optimize for, not game it, trying to optimize this. One is MTTD, which is mean time to detect. Second is mean time to recover, like how soon you are able to recover. And third one is somewhere I will be, the focus of the talk is on MTTI, which is mean time to isolation. This is not an industry standard term, but something that we coined. And it's a subset of MTTD, but usually at the customer or the case study that we are talking about is quite a big enterprise. And they always have this problem. Hey, किस team का ये problem है? Is it an internal team stakeholder? Is it a vendor from which the problem is occurring? Or is it our end users, right? So MTTI, this will actually correlate later on. Some background and context. This one particular case study, 95% of their infrastructure runs in data centers, right? Now, the geography is usually Europe and North America, while that just actually makes sense. We are doing this in December because they have their own peacetime and holidays. The geography footprint is this: 95% is in the data center dependency, and usually the first line of defense is their L1 and L2 support engineers, right? They are trying to handle initial triage. Now, this is the context about the customer and how we were able to solve some problems for them. Their core challenges. There are 3 core challenges that I'll like to highlight. One is missing correlation in runbooks. For example, one particular day, your disk is actually 95% consumed. There is slowness. Your L1, L2 support goes in, fixes it, but for some or the other reason, not able to create a runbook, so that the next time that issue occurs, somebody is able to repeat it. And a lot of these things are cultural problem, but let's accept these facts, guys, right? Entropy in software and entropy in systems is very relatable. As and when you have a bigger organization or a complex piece of software, your entropy keeps on increasing, isn't it? Poor RCA qualities. Now, poor RCA quality, until and unless it depends who is actually making the RCA, what's the process that looks like. It is like, hey, restarted service, found problems or adjusted settings. It's there, but it's very vague. 2 months down the line, people are not able to relate what it even means, right? And high MTTI. This was a very critical. Like the teams are internally arguing and discussing. This is my problem, मेरा problem है, तेरा problem है, या किसी बाहर वाले का problem है. But even to identify, to detect this, that this is not our problem, our system's problem, it also takes up a lot of understanding of your visibility on your systems itself. आजकल मेरा problem, तेरा problem नहीं तो Cloudflare का problem है, right? And what actually happens, because you don't have this culture of RCAs or looking at previously and historically identifying where potential issue can occur, you don't have your learning loop. A lot of engineering hours are wasted because every time an incident occurs, you're starting from scratch and you're scrambling things left, right, center, no matter what. And of course, SREs, as the Google book of SREs says that it should be a blameless culture, but it's always a blame game that's creeping in, right? Now, these are some of the challenges. And of course, business is not at all happy because there are L1, L2 supports. They are trying to offload it to some other teams without even identifying that, hey, is it actually that one particular team's problem? And there is a lot of high cognitive load because no matter what, even if your SRE teams are following the follow the sun model, they will have burnouts because they are always dealing without any structure or without refining the thought process, right? So, and then you have a lot of hours being wasted. And at the end, no matter what, even if we take it up in a light manner, but a lot of business gets impacted, right, at the end of the day. And a business stakeholder will not be happy about it. Now, I'll actually talk about, this talk is also more, I'll be showcasing up a demo. That demo is recorded because I want to actually talk more about and follow along what exactly is in the demo. But couple of things. One is the RCA quality, right? How we were able to improve the RCA quality by saying that historically, look guys, an LLM is telling you that your RCAs needs to be improved and to be better. You imagine that there is a senior SRE in the team who is actually offloaded a lot of the thought process and context to your prompts. By the way, out of you, who uses sub-agents for their day-to-day workflows? Okay, I see a couple of hands. And the idea of usually sub-agents or your prompts, you know, people used to maintain their own config files at a point in time. These days they they offload their agents and keep it in Git. Who keeps it in Git? I'm one of them, by the way. Yeah, cool, right? And then you have the incident correlation. Example, the disk issue that occurred. It is one of that issue that happened there, but you try to identify that was there any kind of a correlation. Let's say the language of that RCA is high memory usage and a memory leak. They are related to memory, but probably are they potentially correlated or are they not, right? For human, it will be very high if there is an incident management tool. Sure, you can do this, but to identify and gauge that, okay, these are somewhere correlation is there, this is where your large language models can be handy and helpful. Root cause isolation. The isolation part of this whole MTTI is that, hey, is this particularly my problem, vendor problem, or an end user problem? To classify that, this is where we were able to leverage LLMs better. Incident correlation, right? Now, context and inputs. You usually, when I asked about the sub-agents, the persona, the position as you have as an incident analyst, I'll show you in the demo itself, but what it looks like. You have your data source. You probably have one query, let's say high memory usage or an SSL certificate expiration, and you have your detailed historical incident list. Now, by the way, I want to talk about one specific thing. These days, a lot of incident management tools, if you end up using a Datadog, PagerDuty, everything has an AI part to it. But the problem here is your SREs or that L1, L2 support, like you have to give context to your AI, you have to give context to your SREs. If they don't have that context, you will always be in a toss, right? Right. So the data source, so the detailed historical incident list is important so that you can actually use them. And then there is a threshold, which is the minimum similarity. Now, minimum similarity is actually some similarity score, which you ask the model that, hey, this is a threshold that I would want you to filter out all my incidents, right? Now, similarity rules depends on multiple things, is components, systems, domains, that is one sector. Vendor, like, hey, this is a payment level issue. Payment may, is it a Stripe level issue or a Square payment issue? Or let's say logistics, is it a FedEx issue? Or any logistic system that you are contacting. Infrastructure level, is it at a load balancer level, or is it at a database level, or is it my a Redis cache or an elastic cache component that is actually involved in this? And finally is your output and validation. So you say that, hey, this is a filtering that you end up doing, and you ask for a specific kind of an output, that I want a fixed JSON that based on the analysis that you do, you give me a name, you give me a score, and give me a reasoning behind it that, hey, why does this actually have a high score? So let's say if as an SRE, I join a team, I can actually run through this and identify that based on the similarity score, this has a high reason that it makes sense that there is a correlation to the previous incidents that we had, right? And of course, you have some kind of a safety checklist where you say that do not do this. You add it in your prompt explicitly. Like, do not mix and match a Stripe issue or a logistics issue, or a a FedEx issue together, right? Second is an RCA quality classification. By the way, RCA quality classification, no matter you use LLMs or not, but if you are able to get a feedback on your existing RCA, that's also good enough, right? That is also part of a prompt that, hey, this RCA should have so and so problems. It should identify what are the root cause, what is the root cause, what are the action items, what are actionables, right? What have been your learnings? And of course, you capture the timelines as well. So you identify it as vague, like clear, vague, and no RCA, right? Because based on the prompt and your existing RCAs, you can go back historically and try to fix them, that, hey, what has been done in retrospective, and it becomes a learning for your team as well, right? Like, if you have multiple incidents, you will be able to improve the quality of your RCA and your culture as well. A lot of things AI will not solve your problem. Your culture also needs to be fixed, how you are actually using your tooling and leveraging your incident management systems, right? Root cause isolation. Now, root cause isolation, as I mentioned, that, hey, you have your incident title, you have a lot of the summary that is present, and you have your classification categories. Internal, that, hey, this is an application code, a microservices, a stateful system, a database, a vendor, SMS, analytics, as I said, logistics, payment gateway. Finally, end user, is it at the client side, maybe a mobile app or a browser, right? Or the user network, if you can have that much of a visibility. And finally is vague, that, okay, if it doesn't fall into any of the category, it is at least vague. You probably need, the system requires more incidents and more data to be fed so that it gets better results going forward. But at the end of the day, the goal is to have reduce MTTI so that there is less blame game in the teams itself. Yeah. What I'm going to do, I will do up a demo here and then actually come back. I'll switch my screen. So this is actually part of my local system, but this is one of the source code repository. So we are using OpenRouter here, right? And using AWS Bedrock, the alternative. This demo is going with OpenRouter. We are just validating this, that, hey, it is validated, right? Then let's actually start with, if you don't want to use any model, we are using DeepSeek at the moment, but you can use an XAI or XAI Grok beta free as of now. A good RCA example. Now, if you see, there is an RCA file, a prompt file, and an incident title which says SSL certificate expiration, right? We run this through, and let's actually wait. So it suggests, yeah, it suggests that this is the incident title, this is an RCA type, this is the reason, right? Now, if you see, it says that the RCA type is clear. What we go and what we do, we try to actually look at the prompt that we had and the RCA. Now, this is the RCA that was created previously, that this is an incident overview. This is a problem analysis, right? The sample data RCA good. This is a root cause investigation, what happened, root cause investigation, manual certificate management, impact assessment, resolution and recovery. This is the detail of a complete SRE can actually think of. Root cause remediation, right? Preventive measures. A lot of these things are actually fed into the system. They are already present historically, and you have your timelines. Next is actually the prompt type that you have, right? What kind of a prompt that you set up. Yep. So find RCA type prompt, and here we look at this. You have the incident context. Now, I would say that if you look at this, there is a title, which is actually a placeholder, a summary. This is a kind of a prompt that I would like to have. And you extrapolate this, with your existing RCA to this prompt, and then try to gauge, is it a clear, is it a vague, or is it actually a no RCA, right? The detailing is here in the prompt itself that you're doing, right? That you define that clearly it should follow a structured analysis approach, like 5 whys, identifies root cause, specifies actionable solution, implementation. Vague has this kind of description, that is that if it falls under this kind of a category, it is vague. And you also define the kind of an output that you would want, that I want to have one particular kind of a response, right? Next is that, hey, this is an RCA vague, which says that, okay, I want to run this vague type of an RCA and see that database connection pool issue that actually happened in the past. Now, this is a connection pool exhaustion. If you see that the detail is not there, it's not very exhaustive here, right? You just say that, hey, it doesn't match up some kind of a structure here, right? And it will say that it lacks a structured analysis approach and whatnot. Cool. And then you do it's one of the RCAs that is identified in a manner. Cool. Then this is a no RCA. The expectation is either it will categorize this as a no RCA, or it will categorize it as a vague. Again, it depends on how that LLM or model that you are actually using underneath. It does this, and it says that it lacks a structured analysis approach, something very similar that we saw previously, right? Now, this kind of helps you to identify that, hey, what kind of an RCA or the detailing that you have in your team. You can actually use this and suggest that, hey, this is the level of detailing that you want, right? Next is querying with the similar incidents. Now, right now, this can be an API call, but we have like a JSON payload which we are actually matching against. So it says an high memory usage service, right? We are trying to correlate some incidents here. It looks at it looks at the JSON payload, and then says, and this is a prompt that has been created separately to identify correlation. We'll get there, right? Now, if you see, it says that high memory usage on service causing performance issue, because that the query was that, hey, I look for a high memory issue here, and there is a minimum similarity, which is a threshold that is 0.6 that has been identified. And we said that based on this, you will see that the similarity score has been provided by the model, and it also gives up a reasoning here that this is a direct match on high memory usage, right? As we progress, it looked at a number of incidents that were present. Then what kind of an incident ID was there? Because even if as an SRE I join, which incident it is pointing to that and had happened in the past, I will not be able to. Now here, if you look at it, right, there is a high CPU it's mentioned, but it says with a very clear reasoning that this is an high CPU usage issue, not an high memory usage in the reasoning itself. That the CPU is the primary focus here, right? It actually gave this kind of a description to us. Good. Yeah. So think of it, right now we are simulating from a JSON payload, but let's say imagine that you have your incident management. Most of these incident management tools have their own set of APIs, right? So you can definitely go ahead and actually understand. Yeah. This is the sample data. Let's say you are making up an API call and you have the collection of your JSON API. And it follows this, most of the time it follows this kind of a payload structure. Yeah. You have your incident, which incident it is. Yep. Then it also tells that which one it actually ends up matching. The third one is that incident similarity score, not the third one, the incident similarity search, how it actually comes up with its similarity score. It identifies the technical components, problem types, symptoms, affected systems, error patterns, and you are giving those instruction to these systems, right? And then there are critical context distinctions. Similar sounding terms may refer to completely different systems, and you are passing this and creating their own set of guardrails here. External service provider, example, Stripe payments, FedEx shipping, SendGrid email, right? These are external services. Anywhere you see them, mark them that, hey, you have to bucket them in separately. Then you have these incidents are only similar to other FedEx shipping incidents, very explicitly with, mentioning, right? And do not, creating those guardrails, technology stacks, different infrastructure or operational patterns, right? And similar matching guidelines, you are saying that, hey, these are the database issues, this is an API issue, infrastructure health checks, provider health checks, performance, right? Then symptom based. This is a connection pooling timeout or a resource exhaustion or degradation, right? Yeah, I probably will. So based on this, you can actually categorize this and then identify. It is very contextual to your system, but you have to think and how a senior SRE will end up doing this, right? And again, you can specify what kind of a format would you like. That, hey, this is a format that I would want. Is it matching, incident ID, incident name, similarity score based on 0 to 1, and your own reasoning, right? And then you say that if it doesn't match anywhere, return an empty array. Yep. And some of the guidelines, so that you actually offload this whole computation to the model itself rather than you trying to do based on the context that has been provided for your RCAs, right? The next one is the correlation incidents, right? Redis cluster failover causing connection drops. Now, if you look at this, it actually mentions for a database replication lag. It says both incidents involve database related issues, because somewhere it was actually mentioned, but the Redis cluster failover and are both represent infrastructure level. They're not exactly similar in the category of Redis level issue, but they are they fall in the category of stateful systems, right? Yeah. Well, I'll move forward. You have your similarity score, and then something like similar, you can actually tell your SRE teams. Final one is the root cause entity type, which is basically the isolation type that you would want. Is it an internal incident, right? You actually end up suggesting that, hey, this is an incident that you had. You have your entity type prompt as well, which we will go through. It says that the incident involves AWS RDS database connection failures in this region, which is a cloud provider infrastructure issue, right? Since AWS is your infrastructure, this falls under that internal category. You are able to identify, categorize them that, hey, this is kind of an issue that my systems have encountered in the past, right? Yeah. And here also, if you see, again, you have your prompt, you have your placeholders where you actually extrapolate at a point in time, and then you do the categorization that, hey, this is an internal system, is it a vendor basis issue, or is it actually something that a client side level issue, or maybe it's a very vague because I don't have enough context historically, right? Yeah. And you actually come up and then have your own decision tree and then the response format that you can have, right? Now, if you run this again, that, hey, probably that this is actually not an actual issue, right? It says, no, this one is a Stripe payment gateway timeout. It says that this actually relates to the Stripe payment issues, and you have some incident that was present historically in your incident management tool, right? Yeah. And then end user incident or a device browser issue that one can have. If you look at this, checkout page probably not loading on Safari iOS 15, that maybe your front end actually captured this, that hey, this is an end user level issue that's present. Yeah. Gotcha. One of the vendor differentiation importance of clear prompts. If your prompts are vague and doesn't have that much of clarity, you will end up identifying and bucketing them in the wrong buckets. Right. So it categorizes as incorrect AWS as a vendor, right? Yeah. And then you identify your categorization criteria as well. You specify as I already discussed. Right. Coming back to these slides, so usually you have these input systems. You have that, hey, this is a critical alert that actually happened. You do try to do up a correlation that there was a gateway timeout or probably latency spike on payments. There are two issues that should technically occur. Then you analyze it and then you try to isolate, hey, this actually belongs to an internal category. Manual process, probably you don't know how much time, but probably with LLMs, you can identify based on that so much of context that this is less than 2 minutes, right? Yeah, this is probably the last slide to actually summarize the work that we are able to do. Something that I have not written here, but I would like to highlight that AI will not actually make great SRE teams. No, it will not. Because as I said, like AI requires context, your team also requires context. Your team requires systems in place. If you don't have an incident management system, you don't have your logging infrastructure or your observability infrastructure, your AI will not be able to help you there, right? The thought process, because people who operate with a lot of sub agents, they know that they try to offload how their mental model is into the sub agents. Similarly, an SRE will try to offload those mental model into those agents or into their prompt. That's the secret recipe. Other than that, of course, the model also becomes very critical, how and where you are using. Then you, of course, you have your memory level. How do you store your memory level issues also becomes another challenge. But yeah, if you see that, hey, this is your incident management systems optional RCA, all of this on the left hand side should be present so that you are able to do, we were able to do the one that is at the center and actually provide outcomes and reduce MTTI at the right hand side. Yeah, that's it. I think I'm done from my side. Any questions? Yeah. Correlate the curve data, with the metrics. The idea is that from curve data, I know which is what is causing issue, but I want to also know that if I, for example, downscale some instance, what effects it will have. So I'll add to kind of correlate with different data points. So my question is that did you try correlation with the structured data, and does LLM convert that into a query and then shoots the answer, or it will how it will work? So if, so your question is that, hey, did you try with the structured data? When you say structured, according to me, the whole text which is actually part of a JSON field, right, is actually a structure for us, right? And then you are trying to read, because it's very deterministic in nature, that API returns a response in a certain payload, and then you are able to capture that field and then you feed it into the system based on the prompt, because based on that you are able to identify that way. Right. Yeah. But the core kind of data which you can really write SQL queries on. Okay. So I'm thinking it might be better to write the queries itself, because it's a one-time task.
than have AI to correlate these things. So I'm just exploring this thing.
Yeah, if I understand, it can be a next level of an iteration. The first is to even identify the domain, right?
Yes.
That's a next level of an iteration
Yeah.
that you can end up doing. I'm pretty sure that you must have done that. That you do the correlation first, and then you actually try to generate that query, right?
Yeah,
Because
maybe. I mean, yes, I'm exploring.
because if
that.
you try to do this in first shot, AI तो कर लेगा, सामने वाला बंदा कैसा करेगा? That's important,
Yeah, yeah, yeah,
right?
correct.
It's it becomes that development becomes like a software iteration process. Of course, end goal is that you do this, but you will probably miss out on a lot of the nuances that you
Yeah.
would actually want, or the correctness that you would ideally want to capture.
Yeah, because I would want AI to make system more dynamic, but sometimes, you know, just writing SQL query would be better. I don't know.
Yes and no, because if I know that system that this prompt is pretty good and I have actually worked over a period of time with this and it gives decent enough results, then I'm sure that, hey, just write up a one-shot query that give me an SQL probably for this.
Thanks.
Go on.
Mainly from like a code perspective, I saw that you have like a Python script you have written. So are you using some framework like LangChain or something to do it, or is it?
No. I think I can go through that code, but not right now. It is actually using a lot of these interfaces, OpenRouter interfaces,
Okay.
and we were using Amazon Q. The open source one was because it's cheap and you can use a free model, and then of course Q ones which are actually provided by the customer.
Thank you.
Sorry, I have multiple questions.
Go on,
So, yeah, that's what I wanted to ask. Should I go one by one, or I can take one? Yeah. Okay, so I'll take one. So I want to know whether if you have already implemented this for customer, or have you internalized it as part of the product offering, and whether customer, how was the customer reaction? Because for example, let's say if I was on the technical side, on customer side,
Yeah.
I may say that, oh, why do I even need AI for this, right? This can be part of my automation suite, because this can be done without AI, just using. Of course, keeping aside the part that the LLMs may or may not be that mature to identify the difference between memory leak, and memory utilization. And you may have to train the LLM, because Apple as a fruit versus Apple as a company. LLM, I mean, I'm giving simple example, but in case of SRE, LLM may not be matured enough to use the correlation and things like that. So just keeping it short,
Great
whether
question.
customer, yeah,
Yeah,
the
great.
customer.
Thank you for
Yeah,
asking this. When we actually went there, we were not saying that we want to solve it via LLM. It was a side effect of it. We were there. This is a problem. How will you solve it? That is point one. The business stakeholder on the other side was saying, I have a plethora. There is a signal versus noise problem for my L1, L2 support. How you can reduce this, right? And the one important thing is we were not disrupting their day-to-day workflows. I am actually like just intercepting on whatever the data that they have. If they don't have that enough data, of course there are, when you have, as I earlier said, large enterprises, a lot of entropy into the systems. So you have to do whatever they have and you have to leverage on top of it. So we were able to showcase this. And look guys, this is what we can identify. We are reducing the cognitive load. I'm not saying that this is a silver bullet that will solve all your problems. And let me call it out. An AI will not solve your replace your SRE. Not at all. But the context that you provide, you can enable and leverage it to make your job better and reduce that cognitive. And probably that was more of a buy-in. And answering to the first question, was it deployed? Yes, it is deployed. On the other side, yes, we have done this.
okay. By the way, thanks a lot. What this does is this validates one of the 25 standard use cases I have.
Yeah.
But no one is validating any of those that it's
Yes.
actually useful and implemented.
Because if you look at the depth of the prompt, you understand the context of the system. Your engineers need to understand probably we had a better vision of the system because we were actually working from top down. We were talking to the CTOs, directors of engineering, to their ground engineers. So we had enough context with us to actually come up with the prompts that, hey, this is the clarification, and get into the details before we were able to actually write those systems for them. Okay.
Hi, Jaideep.
Thanks.
Thank you. This has been very good talk. Great prompts. I had one question that you mentioned alerts and on call, and that's great. That was my question. Did you also tackle that piece that sometimes the all your alert is like there's a slowness in dashboard, which eventually takes some time to reach that there is a Redis slowness or the problem in Redis. So you have you also solved that step? Like from logs that it categorizes.
Yeah, so if the system is actually saying that this is actually vague, it's an a feedback to the team itself that we need to actually do a better job how we write up an RCS. It has to be exhaustive enough so that not for an AI to consume, for an even a human to consume tomorrow. That this every time good SRE teams, when they actually go in, they will always ask, show me your history of RCS. If it is not, that's a red flag. That hey, probably this SRE team is not operating at the level that they should be operating because they don't have the culture of writing good RCS. Some of these RCS, usually the one that I saw, the vague ones, are actually very customer end specific, right? That hey, customer को दिखाना है कि हाँ कुछ तो हुआ था. But internal teams, for the system to get better tomorrow, they have to write it in depth. So if the system says that it is a very vague RCA or it's a very I'm not able to find a correlation, then probably it's a feedback not to the AI, feedback to the humans here.
I think we're on time.
We can take it after.
But yeah, feel free to connect with Jaideep, once the networking session's open. He's happy to take more
All right.
questions.
Thank you, folks. Thank you.
Yeah.